Hello, viewers. Welcome to our lecture on soil science and ecology. Our lecture today will be on soil texture. Earlier, we have looked at some physical properties of soil, such as soil ozonation and soil color. So our lecture now will be on soil texture. What is soil texture? Soil texture basically refers to the proportion of the soil separates that make up the mineral component of soil. It is the proportion of the soil separates that make up the mineral components of the soil. So most people usually have a misconception that soil texture is basically what you feel when you touch the soil. But in the scientific sense, it is a proportion of the soil separates that make up the mineral components of the soil. And the soil separates are called sand, silt, and clay. So the proportion, the percentages of each of these soil separates in the soil determines the textural class of the soil. And each of these soil separates adds up to make up 100% of the soil particle size. Okay, so the proportion of sand, the proportion of silt, and the proportion of clay in the soil determines the textural class of a soil. So it is basically the proportion of soil separates that make up the mineral component of the soil. Now, the soil particles have the following size ranges. The sand particles of the soil range from less than 2 to 0.5 millimeters in diameter. Then we also have silt, which is from 0.02 to 0.002 millimeters in diameter, while the clay particles are less than 0.002 millimeters. So sand particles are larger than the silt particles are larger than the clay particles. The sand and silt are the products of physical and chemical weathering. They are products of physical and chemical weathering. Okay. Clay, on the other hand, is a product of chemical weathering, but often forms as a secondary mineral precipitate, a secondary mineral precipitated from dissolved minerals. Okay, so clay is the product of chemical weathering. Okay, it's a product of chemical weathering, and it's often formed as a secondary mineral precipitated from dissolved minerals. It is a secondary mineral that is formed or that's precipitated from dissolved minerals. Sand and silt are the inactive part of the soil matrix because they do not contribute to a soil's ability to retain soil water or nutrients. They are said to be the inactive part of the soil matrix because they cannot retain water and nutrients. The clay particles, on the other hand, because of their shape-like structure, clay has a large amount of surface area per unit mass, and its surface charge attracts ions, positively charged nutrient ions, and water. Okay, because they are able to attract positively charged ions, which are called cations. Clay is said to be the active part of the soil matrix. They are able to attract plant nutrients or chemical substances. They sequester them for future use. They're able to retain them, preventing them from being washed down. Okay. Because of this, clay is the active portion of the soil matrix. Clay particles are able to retain soil water and nutrients. And because of that, clay is said to be the active part of the soil matrix. These nutrients are valuable to plant roots for nutrition. So clay particles are able to retain plant nutrients and water for plants to absorb to carry out photosynthesis or for them to grow and also make these plants be able to produce food. Clay particles are also somewhat flexible and plastic because of their lattice-like design. They are flexible and plastic. This feature allows clay particles to absorb water and other substances into their structure. Okay. Their flexible and plastic nature enables them to absorb water and other substances into their structure. Now, we want to look at one other very important feature of soil particle size. For all mineral soils, the proportion of sand, silt, and clay always adds up to 100%. So the proportion of sand, the proportion of silt, and clay, when added up, should make up to 100%. These percentages are grouped into soil textural classes, which have been organized into textural triangle. So the percentages of sand, silt, and clay, when analyzed, gives the textural class. And this soil texture is basically ascertained through either the hydrometer method or through the seed method. And the results, the percentages of each of these soil separates, is then compared with the values in the textural triangle. Now this is the textural triangle. On the left-hand side, we have percentage silt. On the right-hand side, we have percentage silt. On the left-hand side, we have percentage clay. Then at the bottom, we have percentage sand. So the percentages of each of these components determine the textural class of the soil. However, there are some terms that are used to describe soils, okay, organic soils, soils that have a lot of organic matter. And such terms are peat, muck, and peaty muck. Now, a soil is said to be a peat when the organic material in it, particularly the plant parts, are still recognizable, while a muck is highly decomposed organic material in which no plant parts are recognizable. Then the mucky peat is decomposition. In a mucky peat, the decomposition is intermediate between the muck and the peat. The decomposition is intermediate between the muck and the peat. Thanks a lot for watching this video. Please watch more of my videos on my YouTube channel, and you'll be glad you did, because there are many educative videos, even on soil science and ecology, on biological techniques, and even on codice, as well as other subjects that are related to biology.